What's going on, everyone? Mr. D here in our second installment for polynomial functions. Today we're going to be discussing end behavior of polynomial functions. Now, end behavior refers to what's going on as I go forever to the left or forever to the right on my polynomial function. If I think of a polynomial graph, and I'm just going to make something up, let's say that, there are two things to kind of be concerned about. Sometimes we'll be concerned about what's going on in this little middle chunk because that middle chunk has mins and maxes, and that can definitely be a value. But then we're also going to be concerned with what I have highlighted in blue, and that's going to be the end behavior. So that's going to be the focus for today, is what does the end behavior of our graph look like? What is the general shape? And we really don't care what happens in the middle for today. So I really don't care about this red stuff. It's just what's going on with the blue. All right. So now if we were in person, I would give you all a sheet of paper that you can kind of see poking out to the right. And it's got a whole bunch of graphs. And I'd give you guys like 5-10 minutes to go to Desmos or TI-84, whatever, type in that graph and just see what it looks like. Now within all of these, what we're going to want to do is start pulling apart relationships between our leading terms. That tells us both the degree and the leading coefficient and the behavior of the graph. So when we graph all of these, here's a rough sketch of what they would look like. Now, if I were to go through and really focus on the end behavior of each of these, I'm paying attention if the arrows, are they going the same way? Are they going opposite ways? What are some patterns that I can maybe deduce from this? So then we would go and continue to discuss. Well, let's take a look at the degree here. So I've got third power, fifth power, so cubic, quintic, cubic, quadratic, quartic, quadratic, degree of 6. And then we would specify, is it odd or even? And then we'd start to make some conclusions. Well, I'm noticing these odd functions, their end behavior arrows are going opposite directions. Meanwhile, the even functions have their arrows pointing in the same direction. Okay. And then we go on to leading coefficients. Again, that's the number attached to that leading term. And really, we're just going to focus on, is it positive or is it negative from that leading coefficient? Is it positive or is it negative? And how does that impact the graph? And then we would look at what's going on the left. Is it rising or falling? And when I say rise or fall, I mean, is it pointing up or is it pointing down? So for this first function up here, we said it falls on the left. So that means this left arrow is pointing down. The right arrow is pointing up, so that means it would be rising on the right. So what we would begin to deduce is that anything that has a positive lead coefficient will always rise on the right. Will always rise on the right. Anything with a negative lead coefficient will always fall on the right-hand side. And then what we'll notice is anything with an odd degree will have opposite behaviors for the left side, right side. Anything with an even degree will have the same behaviors. So with the even, they're either both rises or they're both falls. With odds, you're always going to have one of each. So what we're going to start piecing together is how we can use just the lead coefficient of a function to predict what a graph might look like. All right. So, formal definitions, you know the drill. If you got to pause the video to write it down, feel free to do so. So the end behavior is going to be what happens as the graph goes to the far left or far right. So as x approaches negative infinity to the left, so if we go to the left forever, negative infinity, or if we go to the right forever, positive infinity. We're going to use the leading coefficient test, and we're going to pay attention to two things. We're going to say leading sign of the coefficient. So is it positive or is it negative? And then the degree, and we only care about even or odd. So is it even or odd? As we kind of mentioned before, any function that has an even degree, so x squared, x to the fourth, x to the sixth, eighth, 10th, whatever, it will have the same end behavior on each side. So the left side will go up, then the right side will go up. Or the left side goes down, so the right side also goes down. With odds, you'll always have one of each. One of each. So here are some examples. First one, the fact that the right side is pointing up tells me this is a positive leading coefficient. And the fact that we have one of each arrow tells me it's an odd degree. So positive lead coefficient, odd degree. Second one, the right arrow is pointing down. So I know it's a negative lead coefficient. And I've got one of each arrow. So that means it's an odd. Over here, same logic. Right arrow is pointing up, so it's positive lead coefficient. And both arrows are doing the same thing. So it's got to be even, and flip-flop that logic. Both arrows pointing the same way, but the right arrow is going down, so the lead coefficient would be negative. All right, so now we're going to get into the funky notation. The funky notation. So, whenever you see as x approaches negative infinity, that means you're talking about the left side of your graph, what is happening on the left side. So all of these little cells have an as x approaches negative infinity to it. So left behavior is always going to be as x approaches negative infinity. The right side, when x gets super, super big, that's going to be as x approaches positive infinity. That little arrow between the x and the positive infinity symbol, that's math term for approaches, or goes to. So as x goes to negative infinity, or as x goes to positive infinity, that's math jargon for saying really far left, really far right. And then we'll see f of x. Well, keep in mind, f of x, that's really just saying y, right? So the f of x value, that's just the y values. If it goes to positive infinity, that's saying it goes up or it rises. If it goes to negative infinity, that's saying it goes down or it falls. So anytime you see the word rises, the math jargon way to say that is your f of x value approaches positive infinity or your y value goes up. So anytime you see the word rises, you'll see an f of x goes to positive infinity. Conversely, if you see falls, your y value goes down forever, so your function value goes to negative infinity. So this is going to be very confusing for the first few examples, but once it clicks, it's literally just translating concepts and ideas into mathy notation. Again, if you need to pause the video here to jot stuff down, feel free to do so. All right. A little summary recap. Odd degree polynomial functions have graphs with opposite end behavior, so odd degree, opposite. Even degree, same behavior. We've already mentioned that, but something to keep in mind. All right, example time. And this is going to be the end of the video once we get there. We want to use the leading coefficient test to determine the right and left hand behavior for the following functions. The right and left hand behavior. So first and foremost, let's clarify this whole right side, left side thing. Right side is going to be when our x is going to positive infinity, and then the left side is when x goes to negative infinity. So if you ever see that, that just means the right side and the left side. Let me clarify that negative a little bit more. There it is. Okay. So number one, we've got x to the third minus 2x squared minus x plus 1. The only thing I really care about on this is that very first term. It's already written in standard form. I don't need to rearrange. So x to the third term. I'm noticing that it's a positive coefficient, right? The coefficient's just 1. So the fact that it's positive tells me no matter what, that right arrow is going to be pointing up. Now it's an x to the third power. That's an odd degree. So that means the arrows are going to be doing separate behaviors or opposite behaviors. In between those, we have something happening with the graph. I don't really care. So now let's focus on our end behavior. So I'm going to say the left side and the right side. So if I look at the left side of my graph, and again, I just sketched this, the left side is going down, okay? So the way I would translate that is instead of using left, I'd say as x approaches negative infinity, so as I go to the left on the x-axis, my graph is going down. Down would be negative infinity. So f of x goes to negative infinity, points down. As x goes to positive infinity, our f of x value goes up. So as x goes to the right, our graph points up. When you're setting these up, this will be the same every single time because you're always going to have a left side, right side. So you're always going to have as x goes to negative infinity, as x goes to positive infinity. So this will be the same every single time. The only thing you have to worry about is figuring out the up versus down behavior. With that being said, I'm going to be a little bit lazy, and I'm just going to copy paste this stuff over to save myself some writing. All right, so now that that's out of the way, let's carry on. All right, number 2. This is not written in standard form. Shame, shame. So what I need to do is find the highest exponent right here. So this is the term that I care about. So this graph, I know 2 things about it. It's got a negative leading coefficient, and it's got an odd degree. So negative leading coefficient and an odd degree. The fact that it's negative means the right side is pointing down. The fact that it's odd means the arrows are doing opposite things. In between, the graph does something. Who cares? So now when I want my odd or end behavior, I need to figure out what is the left side doing, this left arrow, what's happening? Well, it's pointing up. So f of x goes to what? How do I say up? F of x, or the y value, goes to positive infinity. Why can I not draw infinities today? Holy cow. If I look at the right side, as x goes to positive infinity, what is this arrow doing? Well, it's pointing down. So f of x goes down. That would be f of x goes to negative infinity. Number 3. Again, not written in standard form, so I need to find the highest exponent right here, x to the 4th. That x to the 4th term is positive, and the degree is even. The fact that it's positive tells me the right arrow is pointing up. The fact that it's even tells me both arrows are doing the same thing, so the left arrow has to also be pointing up. In between, the graph does something. I don't really care. So for both of these, both the left and the right arrow, they're both pointing up, so my y value is going up in each side, so f of x is approaching positive infinity. If it's going up, it approaches positive infinity. Negative 3x to the 6th for number 4. Next one. Hey, this one is written in standard form. How fun. So this is the only term that I care about. Just looking at it, I know 2 things. It's negative, and it's got an even degree. So it's negative and it's even. The fact that it's negative tells me the right arrow is pointing down. Regardless of even or odd, the fact that it's negative means the right arrow is pointing down. The fact that it's even tells me both arrows do the same thing. So if one is pointing down, the other is also pointing down. In between, math happens. I don't really care. So on both the left and the right side of this, our arrows are pointing down. That means our y value is decreasing. Our y value is falling. The function value is going downward forever. So we would say f of x approaches negative infinity. And since it's even, both of these blanks will match. So just to recap, on the even functions, the end behavior does the same thing. So if you know one end behavior, you know the other. On odd functions, you have one of each. So you have one will be a positive infinity, the other one will be a negative infinity, and use the right arrow to kind of guide you based on the positive or negative aspect of it. And I'm noticing now that my font size slowly increased as I went. How fun. All right, that's all for this video. You know the drill, people. If at any point you have a question, do not hesitate to reach out and ask. And as always, folks, good luck, have fun, be safe, roll tide.